Hello, everyone. Today we're going to be talking and going back in time and refreshing our memory about linear and exponential functions as well as quadratic functions. We studied linear and exponential functions in first semester, and we not only wrote equations and graphed them, but we also looked at their table of values to see how we could determine that it was exponential or linear just by looking at the table of values. Well, here's our first example where we have this table of values. And what you'll notice is if I am trying to go from -10 to 3, I have to add 7. To go from -3 to 4, I have to add 7. 4 to 11, I have to add 7. And 11 to 18, I have to add 7. When this happens, when all of those values are the same, this is a linear function. This has a constant rate of change. They're going up or potentially down by the same amount every single time. So this is called a linear function because the first differences are the same. And what I mean by differences is the difference between our y values as I'm going along the table. This we also talked about back in the day as being an adding or subtracting pattern. If you're not sure what the pattern is, oops, wrong pen, you can always subtract backwards. So what I mean by that if you have some trickier numbers, if I'm not sure how to go from -10 to -3, I could do -3 minus -10, and that will also give me that pattern. So adding 7, and I could do that between every single one. 4 minus a -3 is 7. 11 minus 4 is 7. Every single time I subtract backwards, I get the same amount. So those are our first differences. First semester, we also talked about exponential functions. When we have an exponential function, what we noticed is that we constantly get bigger or constantly get smaller, but they're not adding and subtracting the same amount. I mean, you could just look here and say, is the difference between 12 and 4 the same as 324 to 108? And I think it's pretty clear to say, no, those don't have the same difference. But what we will notice is that there is a constant multiplication pattern. Now, this one is a little bit trickier to find. So as a reminder, you can always divide backwards to find that multiplication pattern. This is also called the ratio, oopsies, the ratio of the y values. What a ratio is when I divide backwards. So if I did 108 divided by 324, I would get 1/3 or 0.33 in my calculator. Then if I did 36 divided by 108, dividing backwards, I would get 1/3 as well. So we can see a pattern developing here. If I divide backwards for all of these y values, I get a multiplication pattern. There are other ways to show this. You could also use multiplication to show that it's going from one to the next, but dividing backwards also works. Now, the last one that we want to talk about today is our newest function, and it is a quadratic. Quadratics are kind of crazy when you start looking at the table of values, because if I were to do the ratio, so if I divided 5 divided by 2, I would get 2.5. If I did 14 divided by 5, that doesn't equal 2.5. So there's not a multiplication pattern or a constant ratio. If I look at the adding and subtracting pattern, it's also kind of gets us stumped, because to go from 2 to 5, I add 3. From 5 to 14, I add 9. Now, because I know what's coming, I'm going to keep going here. Okay, and you'll notice this is not a common pattern. So many people would just stop here and say it's not possible. But because we're learning about quadratics, what we are going to look at next is we are going to look at, I'll use the same color, the differences of the differences that I just found. So we're going to go one more layer, and we're going to see, how do I go from 3 to 9? I add 6. How do I go from 9 to 15? I add 6. How do I go from 15 to 21? I add 6. This is what makes quadratics unique, is that their second differences are the same. So there's not a straight adding and subtracting pattern like linear. There's not a straight multiplication pattern. You have to go 2 layers into the differences to see that constant amount. So here's a couple examples. So if we look at this one, if I thought, oh, what are we adding? Well, I'm adding 1.5 here, I'm adding 6 here, I'm adding 8, 18, 28, 24 here. And then I'm adding, oh gosh, something quite big, 96, I think. If I did the math, I could figure that out. But even if I went to the second layer, right, I'm not going to get the same number here. This would be adding 4.5 and then 18, I think, so on and so forth. So it's not linear and it's not quadratic. So I'm going to bet, if I had to guess, that this is probably exponential. But what I would want to do is check to see if there's a multiplication pattern. If I look at 2 and 8, I know I have to times by 4. So let's just check to see if that works for all of them. And it checks out. The other way, as a reminder, you can show that this is exponential is to divide backwards. So if I did 8 divided by 2 and 2 divided by 0.5, 32 divided by 8, every single scenario of dividing backwards gives me the same ratio of my y values. So this is exponential. Next one. If I look at my adding and subtracting patterns, I'm minusing 12 to go from 12 to 0, minusing 4, then I'm adding 4, and then I'm adding 12. So this doesn't seem like anything as of right now, but let's look at that second layer just to be sure. To go from negative 12 to negative 4, I have to add 8. From negative 4 to positive 4, I add 8. And positive 4 to positive 12, I add 8. Because the second differences are the same, we would call this quadratic. And our last example, go from 0 to 2, I'm minusing 2. Oh, from 0 to negative 2, I'm minusing 2, minusing 2, and minusing 2. Wow, since all of those are the same, we have a linear function. That first layer or the first differences are all the same. Now, what are we going to do with that information? We're going to actually have our calculator write equations for us, but we have to know what type of function it is. So the calculator steps, we will have to use that stat button, and then we'll have to press enter, which is going to get us into the edit menu. In the edit menu, we have to type the x values and the y values into L1, L2. If your calculator doesn't show L1 and L2, that's something you want to talk to your teacher about so that they can help you get those lists back. Then we're going to press stat again. We're going to scroll to the right, because that's going to get us into a different menu. And then we're going to have to select the type of regression. Regression means the calculator is coming up with the equation for us. We're going to have 3 options. We're going to have linreg, quadrad reg, and expreg. And you pick one of those. You don't pick all 3. We're going to use linreg if we have a linear function, quadrag if we have a quadratic function, and expreg if it's exponential. Then we are going to press enter. And sometimes depending on your calculator, it might require you to press enter multiple times until you get something that has an A equals, B equals, et cetera, and you see some numbers. So you should have numbers on your screen to know you're done. Then you're going to write the equation. If we have a linreg, it's going to look something like ax plus b. If we have a quadrag, it will look like ax squared plus bx plus c. And if we have an expreg, it'll look something like a times b to the power of x. And every single a and b will be replaced with the value, oh, and c, replaced with the value that the calculator tells you. So let's do this example. First, we need to start by figuring out what type of regression is this. So I'm going to start by thinking about what is the difference between negative 9.3 and 2.9. Now this might be something harder for you to do in your head, and so if you wanted to use a calculator, what you could do is subtract backwards 2.9 minus negative 9.3. This is going to give us a difference of 12.2. So that tells me I'm adding 12.2 to get from one to the next. Then I want to figure out the next one. And again, if that's tricky to do in your head, you could do 9.1 minus 2.9, and that should give you the difference, which I believe is 6.2, I think. So I'm adding 6.2. Now this next one should be a little bit easier to do. We're just adding 0.2. And now in this last one is kind of weird because we are actually getting smaller. So again, I could go to the calculator and I could do 3.5 minus 9.3, which is going to give us negative 5.8. All right, so we can notice that those obviously aren't the same, but let's look at that second layer and see if we have any patterns here. To go from 12.2 to 6.2, I have to subtract 6. To go from 6.2 to 0.2, I have to subtract 6. And to go from 0.2 to negative 5.8, I also have to subtract 6. So the fact that all of those second differences are the same, we know that this is quadratic. What that's going to help us do is write an appropriate equation for this table of values. So let's get into the calculator. Just pulled up the calculator from the MCA website, which is linked on your Schoology page, and I'm just going to go through these steps. First button I'm going to press is Stat. It's right by the arrow keys, and then I'm going to press Enter to get into that list. I'm going to have to type in my X values into my L1, so -2, -1, 0, 1, and 2. Make sure you're double checking your data so you're not making any typos. And then in my list 2, I'm going to type my Y values, which is -9.3, 2.9, 9.1, 9.3, and 3.5. Again, oops, see, I made a mistake. It's good to go and check your data because if you type in the wrong numbers, the calculator is going to give you the wrong answer. And I can see another mistake I made. This should be 2.9 versus 2.6. It's pretty easy to go in and fix your numbers just by typing over the values you have. Now that my list is ready to go, I'm going to press Stat again, and then I'm going to scroll to the right. This gives me a ton of options of things, linear regressions that I can do. So you'll see number 4 is a lin reg, number 5 is the quad reg, and actually off the screen at number 0 is X reg. We decided that that table of values was a quad reg, so I'm going to choose that option number 5. Now here's where I get into this weirdness with this calculator, is I have to scroll down to this calculate and press enter. In some calculators, you will just have to press enter one time. Here it tells me that A is -3, B is 3.2, and C is 9.1. The other helpful thing that it will tell you up at the top is the form the equation should be written in. So you should automatically know where to put these numbers at from this very first line it gives you. If your calculator gives you extra information like r or r squared, that's okay. You can just ignore it for the time being. How we are going to write our final answer for this problem is I'm going to write it in that ax squared plus bx plus c, but I'm going to put my values in for a, which was -3 x squared, my value for b, which was 3.2 x, and then my value for c, which is 9.1. So this is the quadratic equation that represents this table of values. I hope that helped. Have a great day.